had colleges and universities from all over the United States and from other countries kind of converge on Harford County Airport at the Service Engineering Unmanned Research Facility. And they've taken drones that they've designed over the past several months and tested, and they've gone out for competition. And there's all different types of designs, all different types of ideas. It's really innovative, and it's a great opportunity for these young engineers to kind of stretch their wings and give it a shot.
So our aircraft was based on a design that we think is perfect for this exact competition, meaning that there's a lot more horizontal flight time than there is vertical flight time. So we tried to save weight on a bunch of servos and extra motors that we didn't need, and that came up to the tail sitter design, which is when the plane itself kind of sits on its tail as it lands. So we came in and we were 1.6 pounds over. That very night, our wings are made of foam, and we basically just went ham on it. We were able to just remove as much styrofoam as possible, and then we just put the membrane back on top. We reweighed it, and we came at around 19.9 pounds, which is 0.1 pounds under the limit, so we're pretty happy about that one too.
One of the big things that we're looking at is getting away from the typical, quad rotor design, or just, hexa rotor, etc. Doing something a little more unique that can perform really efficiently in two flight modes. And so the LPC, Lift Plus Cruise especially, is it's easy to fabricate, pretty simple control laws compared to things like tilt rotor, tilt wing. Just makes it a lot easier to control, especially. Basically, the design from start to finish is modular, and so we're 3D printer fanatics, you could say. We have a few of them, so we like to print everything, even when we shouldn't. And basically, what we were able to find is it's a really quick and light way to, relatively lightweight way to print out complex shapes, such as an airfoil. There's no real machine work involved. You simply make it in a CAD program, and boom, it's there in 6 hours. Essentially, we're a Lego factory that has a bunch of extra parts, and we undo it, put it back together, and it's just a quick process. After sitting down with it last night for several hours, we were able to do a lot of testing, a lot of simulation in our program, and basically fine-tune the navigation as best we could for today. And honestly, we were just really glad to see it land in the hoop at all. So.
We learned that things in the real world and things in simulation models differ a little bit, and so sensors have noise, sensors can fail, motors and electronic speed controllers can fail.
Yep.
And these will happen in the field. They don't happen in the simulation models, so you have to try to design to be robust to these things. Get involved. Vertical flight is more challenging than fixed wing forward flight, and just come out to the competition. Let the competition grow. VFS is doing a great job to host this competition, but it's only going to grow if there's more interest and active participation from teams.
Probably the most impressive thing has been the resiliency of the teams. Anytime you're taking a brand new design out and test flying it, there's a lot of things that could go wrong, and we've had some hard landings, but the teams have refused to quit, and they have had their airplanes back in the air quicker than I think I would have expected. And it's been wonderful to see the young engineers and face